The iPad did not, wouldn't upload to the computer. And the video quality wasn't enough to where you could see really read the writing on the board, is what people told me. Okay, so the whole point is that now, hopefully, if I zoom in and whatever, you can actually read the writing and fill in the notes as you go. All right, so today is Tuesday, January what? 12th? Well, last night was a late night and an early morning this morning, so anyway, so we're at Advanced Level Chemistry here at Spain Park High School, and if you're enjoying these videos, please feel free to subscribe to my channel.
I accidentally watched that AP Chemistry video the other day.
You did?
I was so confused at what was happening.
So you went online and just went to Mr. Hobbs?
I just went to the Mr. Hobbs YouTube thing and watched the AP Chemistry because all I read was chemistry. And then like 3/4 of the way through the video, I was lost.
That's probably why you don't understand anything.
You're not watching the right video. Okay. So if we look at that worksheet, okay, and number 1 was SO3. Now we've already drawn the Lewis dot structure for SO3. And it looks something similar to this. Okay? We all have that. Now if you had the double bond here, double bond there, then you know you might have had it in a T shape, all that's fine. Okay? As long as you have 2 single bonds and 1 double bond in the molecule. So that's the Lewis structure. So now what we want to do is we want to determine the hybridization. Well, we use our generic formula as a stepping stone to get to the hybridization. So what's my AX formula going to be on this?
AX3.
AX3, right? Now that's not an answer to anything. That's just a way to get to the answer. So I know that there are 3 areas around where the electron density, we call them electron domains, where the electrons are going to be. 3 places, 1, 2, 3. Okay, the sigma bonds determine the shape of the molecule, not the pi. So, what type of hybridization adds up to 3? sp2 hybridization. Okay? That's all you need to know on hybridization. You don't have to go into, I went into the how and the ground state, the excited state, the hybrid state. You don't have to ever draw like I drew because my drawings are pretty lousy and I never expect you to do something I can't do. So, sp2. So now you go to the sheet that I posted and gave to you and you look at the molecular geometry. And so you go to AX3. And what's the shape of AX3? I think Caroline's the only one that has the sheet.
Trigonal planar.
Trigonal planar. Okay? Trigonal planar. It's going to look like this. SO3. Okay? Here's the double bond. Okay? Well, I'll do this.
Yes, I print things out when teachers give them to me.
Yes.
That's a new
Take
concept.
lessons. Learn from Caroline.
Yeah, my printer, I like email it to my dad, and my dad has to like run it. Like it's just a lot easier just to get them in the house.
I just have every school app downloaded on my phone.
Answer it in class.
No, you're gonna need it.
Do I need to get this?
No, because those people at home can be looking on their computer and pull this up because it's all downloaded on their computer.
Okay.
Original plane.
Okay, so now this is always going to be given to you. Okay? So we come here and we find AX3. It's sp2 hybridization. It's going to be trigonal planar as far as the shape. Now the sheet, well, in an ordinary year, I would give you all of this information. You wouldn't have this column. Okay? Because I want you to be able to figure out the type of hybridization on your own. But this year, you know, everything's open book, open notes, so I can't really test you on anything. But, okay, so now sp2, so then we say trigonal planar. It's kind of a redundant name because, okay, trigonal planar. Because this shape, a triangle is always flat. The definition of kind of a triangle is it's only 3 points define a plane, okay? But this is what it's gonna look like. Here's your double bond, single bond, single bond, trigonal planar. What's the bond angle going to be here on these interior angles? 120, because it's going to be a circle. It's going to be 360 divided by 3, right? This is why you learn geometry, so you can apply it in a real course. All right, so that's, what's number 2?
HNO2.
No, HNO2? Okay, so we've already drawn it. Okay, and remember the hydrogen's going to be on the oxygen. And it's going to look like that. Now you could have the oxygen, I think I originally drew it with the oxygen on top. Doesn't matter if it's on top, on bottom, as long as you have a double bond, single, here. Now in this case, we have 2 essential atoms. Essential atom is anything that has 2 atoms bonded to it. Okay? So this one right here, the nitrogen, what's my AX formula?
AX3.
No.
AX.
AX2
E.
with an E for the lone pair. But it still adds up to 3. It's still going to be 3. This lone pair is still going to occupy that 3rd spot of that triangle. Okay? But we're going to say the shape is bent. 2 plus 1 is 3, so what type of hybridization is it?
SP.
sp2. Whereas this oxygen, its AX formula is what?
AX2E2.
AX2E2, which tells me then it's going to be bent. Now I have, it adds up to 4. So we're going to be, what type of hybridization?
SP3.
sp3. Let me know if that goes off because I forgot to put it on Do Not Disturb so the minute somebody texts me. 3? Which one?
SiO2.
SiO2. Okay, so it's going to look like this. So what's my AX formula?
AX2SP.
It's AX2, which makes it SP, and what's the shape going to be? Linear. We just go down here, look, AX2, SP, linear.
That means yes, because
Well, normally it would be, but this is going to be an exception, which we're going to learn about later on this unit. This is actually sand, silicon dioxide, which also makes glass, quartz, and things. And so it doesn't do the normal type bonds that molecules do to one another. And it's just, there are 5 things that are exceptions. We're going to learn those 5. Diamonds would be another one. That's an exception. Number 4. What's number 4?
I3.
I3 minus. Okay? So is and what does the minus mean?
electron.
Extra electron. So when we did the Lewis structure, we ended up having 3 electron pair around the central atom. And when it's an ion, remember you put it in brackets with the charge outside. Now, here we go. What's the AX formula? We only look at the central atom. That's the only thing we look at. What's the AX formula? AX2, 1, 2, and then how many lone pairs?
E3.
1, 2, 3. E3. So you got to come up here, AX2, E3. We don't do, this is an expanded octet. Expanded octets, they used to think that there were d orbitals involved with it, but in the past 10 years, research has shown that the d orbitals aren't involved, and the bonding is way more complicated above what we need to know. Okay, so we don't have any hybridization for anything that's expanded octet. You don't have to do the hybridization. Only for things that obey the octet rule. Okay, so we don't have to worry about that. Then we just go and look at the shape. The shape is going to be linear. All right, 2 more, and then I'm going to let you go. Are y'all seeing how to do this? Can you see how it's very important, though, that you draw the Lewis dot structure right? So if you don't have the right Lewis dot structure, everything else is gonna fall off the wagon. So number 5 says, which one? What's number 5?
CCl2F2.
CCl2F2. I think I went off on a tangent on Freon on this the other day. So we look like this: chlorine, chlorine, fluorine, fluorine. So that's what your Lewis dot structure looks like. And again, it doesn't matter where the fluorines and the chlorines are, as long as you have 2 and 2. They can be in any position, okay? You're just not gonna put them in a chain. They have to be built around the carbon, but it doesn't matter if the chlorine's here, the chlorine's there, fluorine, you know, we just got your 4 spots. So what's my AX formula for carbon? AX4, so what type of hybridization is that? Well, that's the shape, is tetrahedron,
That's SP3.
and it's gonna be SP3 hybridization. Any questions at all about how to do what? Does everybody understand how to get the AX formula? Okay, really, once you have the AX formula, everything else, that's your Rosetta Stone. That helps you to figure everything else out. And then last one is 6 is
NF3
NO3
and F3.
and F3. Big difference. Okay, so what's my AX formula here? Go ahead, Caroline.
AX3E.
AX3E. Okay, because we got the lone pair, but 3 plus 1 adds up to 4. So Clay, what's the hybridization going to be?
SP3.
SP3. 3 plus 1 equals 4. 1 plus 3 equals 4. Okay, and so the shape is going to be one's a lone pair. So we start with a tetrahedron, but we have a lone pair. One leg is a lone pair, so we say the shape is trigonal pyramidal. It's a triangular based pyramid. Okay, it's gonna look just like this. Notice the electrons are still at the points of a tetrahedron, but we don't have anything up here, so we only play dot to dot with the nuclei that are present. So we're gonna say trigonal pyramidal. And if you just said pyramidal, that would be fine with me. But trigonal pyramidal is the word. So this is what you need to do now. I want you, so 7 through 15, you need to go through and you need to draw the Lewis dot structure. And then you go through and do your AX formula. I mean, you don't have to do this. You can just visually do this in your head if you want to, because that's not an answer to anything. But you need to know the shape and the type of hybridization. Got it? All right. You got the rest of the period to work on that.